This is the first of two videos on graphing a parabola. And the first way we're going to graph this parabola is just use the old-fashioned t-chart, plug these numbers in and do the arithmetic. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. These are all positive values because anything squared is positive. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. On the next screen, you're going to see this parabola already graphed using these points. In blue here, these are my ordered pairs that I plotted, and then I just drew the curve around those. This is what every parabola looks like, some sort of U-shaped curve. It may be straight up and down, it may be upside down, it may be fat, it may be skinny, it may be moved around, and those are all the things we're going to look at in this video and the next. A couple terms you need to be familiar with. Vertex. This is this point down here, which is what we can call a turnaround point because it's coming down, it hits rock bottom, and then it takes off again. For this particular parabola, the vertex is the point 0, 0 because it's the origin. Axis of symmetry. Axis is another word for line. The line of symmetry is the line about which this parabola can fold. So if I can think about this line being drawn right down the middle, if I fold this parabola across this green line, that point lands on that point, that point lands on that point, that one lands on that one. And that means that this parabola is symmetrical. The line of symmetry for this parabola is the one that goes right through the origin. It is the vertical line x equals 0. Always x equals because for this type of parabola it is a vertical line. 0 because it's just the first number out of your vertex. So if you can name your vertex, you can name your axis of symmetry. This parabola opens up. The domain of the parabola refers to the x values. I could have used any x value in the world in my chart, any x value. That means the domain is all real numbers. And the way I will write this is to use the interval notation because that's just a little bit easier than using set builder notation. The range is our y values. Notice we don't dip below the axis. Our lowest y value is 0, and it goes on off to infinity. So that's your domain and your range. What I want to do now is show you some that have already been graphed. You could type these into your graphing calculator and look at them that way. This is the same idea. They've already been graphed. Let's see if we can name these things based on the graph, and then from that, maybe we can figure out some sort of shortcut for graphing these parabolas. Looking at this picture, this is the same one we had on the other side. The vertex is 0, 0. Axis of symmetry, x equals 0. It opens up, and the domain is this negative infinity to infinity. I'm not going to write that every time. Your domain for the parabola is always negative infinity to infinity. Your range, however, is going to vary, but the range on this one is going to start at 0, and it goes on up to infinity. Now notice how this changed. Our equation is no longer x squared. It says x squared plus 2. And look what happened to the parabola. It shifted up 2. Plus 2 here shifted the parabola up 2. It moved our vertex up 2. It is still 0 because we haven't moved left or right any, but it did move up 2. That means our vertex is 0, 2. Our axis of symmetry is no different from what it was a minute ago. It's x equals 0. This opens up. The domain is the usual, but the range now, the lowest y value is 2, and then it goes to infinity. Over here, x squared minus 1. Take a look at your picture. Where did the parabola go? It moved down 1. Since it moved down 1, our vertex is going to be 0, negative 1. Axis of symmetry is still x equals 0. It opens up. The domain is the usual, but in this case, the range is negative 1 up to infinity. Now, do you notice anything? When we have x squared plus something or x squared minus something, our vertex is 0, that number. Look at both of these pictures. Both of these parabolas are upside down. And what's making them upside down is this negative that's in front of the x squared. The vertex is still 0, 0, which means my axis of symmetry is x equals 0. Now it opens down. The domain is the usual. With your range, you might be tempted to try to put 0 in the front of this range, and that's not right because we have to go from the least y value, which is negative infinity, and it goes up to a height of 0 with a square bracket on that. So the only thing different in this really is how it opens and how we write the range. The vertex on this is going to be 0, comma 2. Like we said a minute ago, this said plus 2, so that 2 right there went to the second part of the vertex. Axis of symmetry, x equals 0, because whatever the first part of the vertex is going to be my x equals on the axis of symmetry. This opens down. The domain is the usual, and the range is the same idea. With this, I've got to start with negative infinity, and it reaches a peak at a height of 2. So, first general idea, if your parabola is in this form, y equals x squared plus k, then the parabola has been vertically shifted by k units. If k is positive, it has moved up. If k is negative, it's moved down. And the vertex then is written as 0, comma k. Whatever this is going to go in this position. This is very similar. The only difference is that negative in front is going to tell us that it's going to open down. This does not change the vertex. The vertex is still 0, comma k. Let's see if we can put this all together. Let's look at this, x squared plus 1. This fits the format of what we just looked at. The vertex must be 0, comma 1. Will the vertex always be 0? No, but in this format, when it just starts out with x squared, it's going to be 0, comma that number right there. The axis of symmetry, x equals 0. Because this is a positive x squared, it opens up. The domain is our usual, negative infinity to infinity, both with curved brackets. The range is going to be easier to name if we try to do a little graph on this. The vertex is 0, 1, so I put my dot here. It is opening up, so I know the curve does something like this. Is it that fat? Should it be skinnier? I'm not sure. We'll talk about that later, but that at least tells me what it looks like in general, which will help me name the range. The range is going to begin at 1 and go on up to infinity. All right, another set of changes here. Notice in these pictures, these parabolas have not moved up or down any. They've been moved left or right. And take a look at the format here. We have x plus 2 squared. And this x plus 2 squared moved my parabola to the left 2. So my vertex is negative 2, comma 0. Now the reason we know it's 0 is we can look at the graph. The reason it's 0 from the equation standpoint is there is nothing written after the x squared part. That's why this is 0. This goes right here, but we change the sign. This means my axis of symmetry is x equals negative 2 because it's always x equals the first part of the vertex. This opens up. The domain is the usual. The range, the least y value is 0, and it goes up to a height of infinity. X minus 1 squared, our vertex is 1, comma 0. The reason it's 1 is because of that number right there, but we change the sign. The reason it's 0 is because there's nothing back here. Axis of symmetry is x equals 1, opens up. The domain is the usual. The range, the least y value is 0, and it goes to a height of infinity. So, if your parabola is in this form, y equals x minus h squared, something with parentheses. This constitutes a horizontal shift, and the vertex is h, comma 0. Be sure to change the sign. So looking at this, that says x plus 3. My vertex needs to be negative 3, comma 0, because there's nothing back there. Axis of symmetry is x equals negative 3. It opens up. This one, the negative in front, does not affect my vertex any. That says x minus 4. So the vertex will be 4, comma 0, because there's nothing back here. Axis of symmetry, x equals 4. And this one, because that's a negative, opens down. More on the next video.